How do we manage the protein transition? Which food components can provably boost your immune system? What's the best way to validate health claims for food and food components? Listen to our food and health experts discuss the biggest questions facing the food, nutraceutical, and food ingredient industries today. Welcome to NIZO Talks Food and Health.
The market for meat and dairy alternatives is growing at a massive rate. But while these plant-based products may deliver as close an eating experience as possible to their animal-based counterparts, the food safety challenge they present can be very different. To find out more, we spoke to Robyn Eijlander, scientist food safety and microbiology at NIZO. The market for meat and dairy alternatives is growing at a massive rate, and while these products deliver an eating experience as close as possible to the original products, the safety aspects deliver a real challenge. Today I will be talking to Robyn Eijlander. Robyn Eijlander is Senior Project Manager at NIZO in the field of food safety and microbiology. Robyn, welcome.
Happy to be here.
So that's a very important subject. If we can dwell on that a little bit already, how does food safety picture for plant-based differ for animal-based products?
Well, I guess there are multiple factors that play a role there, but I think the main differences are the wide variety of ingredients to choose from. And on the other hand, also how these ingredients behave during processing and development of the products. Yeah. So if we compare this to dairy, for instance, there's basically one main ingredient, and that is raw milk. And that is pretty consistent in terms of nutritional value, but also of what we know about microbial contaminants. And if we look then into the transition to plant-based, there's a wide range of ingredients to choose from. There's the legumes, and you've got the seeds and the nuts and the cereals, and within those groups there's different varieties, also different types of the same ingredient source. So with pea, for instance, you can have a pea flour, but also a protein concentrate, a protein isolate. Yeah. There's hydrolysates, there's pastes even. So there's a wide range to choose from, and also the microbial contaminants that can be present in all of those ingredients may differ. So I think that is a very important aspect. If we look into also where these ingredients come from, they're all grown on soil. Soil is a natural habitat of many of these contaminants, but also geographical location can play a very important role in the levels and the types, but also climate can have a huge influence. So one harvest may be different from another. Yeah. So there's a great variety there. Yeah. And then also the way they behave, so to say, in the processes. The solubility may change, may differ from also what we're experiencing in dairy. Also the way they respond to heat treatments. So the processes you can apply to these ingredients is also different. Very different.
Yeah. But it's also often said that the microbial contamination in plant-based foods is less well understood. And is that true?
Well, I guess in a way that's definitely true, but it's also understandable if you think where we're coming from. So if we make this comparison to dairy again, there's been decades of research basically yielding lots of data and insights, but also general practices, regulations, even predictive models. And these cannot necessarily be translated directly to these plant-based ingredients. So we basically have to start over there.
And what are, let's say, the major microbial contaminants that we could expect?
Well, some are usual suspects and are quite similar to what we know from dairy. Raw milk also comes from the cow and the same sources there. So we see a lot of spore formers like the bacillus species, also anaerobic species like Clostridia. There's the more thermophilic species like Geobacillus. They also produce very heat-resistant spores. Yeah. And then there's also some new ones, also some ones that we haven't investigated in great detail. Also yeasts and molds are more relevant, I suppose, to these type of ingredients that we're still dealing with. Yeah.
So that means that the let's say ways to inactivate it can be different. If you talk, for example, pasteurization, would you expect that more extreme heat treatments than pasteurization will be required?
Well, I guess from a microbiological point of view, I'd say yes. The higher the heat treatment, the better, especially for these spore formers. But that's simply not possible if you look into the nutritional value or maybe even the perception and the taste of these products that you're making. So there needs to be a tight balance into what kind of heat treatments you can apply and the actual quality of the food that we are producing. So a higher heat treatment is definitely necessary to inactivate especially the spores, I would say, but not always possible for these types of foods.
And so this is the thermal treatment, but can you also think about and dwell a little bit about non-thermal treatments, and are they possible?
Definitely. So that is definitely also something that we're going to investigate in the upcoming years. There are also, from our knowledge within the dairy industry, alternative methods to use other than thermal treatments. Bactification is a good example that has been used in milk. It's really been shown to reduce, for instance, spore levels, but it's very much dependent on the solubility of the product. So can only be applied to very liquid products. So if you're looking into yogurts or plant-based cheeses, that's not possible. There, I think we can definitely look into the possibility of applying fermentation strategies. That has been used in dairy. So the bacteria that are added are basically converting the sugars that are present into acid, and that inhibits then the growth of these contaminants. But the sugar composition and the fat composition, the protein composition is very different from the dairy products that we're used to. So we don't know yet which starter cultures we could use and how well they then inhibit the actual contaminants that are present in these foods.
And what type of sugars probably you can add to to make that happen.
But we do have an example where we have used a fermentation, a natural fermentation in a plant-based yogurt, and compared it to, for instance, a chemical acidification of that same yogurt. And we show there that the natural fermentation effectively inhibits the growth of the molds, whereas the chemical acidification did not. So there's definitely merit in investigating that further.
And which means that fermentation can deliver other benefits which chemicals cannot deliver.
Definitely, yes.
So it's a very complex world to come up with this. How would you think you can find a way through such a complexity?
I think it needs to be done step by step, but throughout the whole chain. So it's really a holistic approach, multifaceted approach. Different expertises and backgrounds need to be combined to really tackle these issues. So we're at NIZO, what we also do is we look into the start of the chain, the ingredients, how are they being produced, what kind of knowledge can we gain on how they're being processed for all of these different types, what kind of microbial contaminants are present, levels, types, but also their characterization. So there's a great variety between species, but also between strains of the same species. So understanding that more, what are the heat resistance profiles, what are their growth limitations, that's really important. So that's microbiology. And then there's the part of the production of the actual products, what kind of processes are being applied, what other type of ingredients, and then, of course, the final product as well. How is it being stored? How is it being transported? What kind of microbes can grow? Is there anything you need to add to inhibit that growth? Also from a safety perspective, can toxins be produced in those products? So all of those aspects need to be put together. And if you're generating a lot of data on that, you can also put that into existing models that we already have available and really adapt them and make them suitable for application towards these specific products. So predictive modeling can be a very valuable tool.
So basically what you're saying, we're at the start of a lot of things that are ahead of us. A lot of things are not known, need to be found out. But I think what you are also saying is that you can build on the knowledge base that already is available from another world, namely the dairy world.
Definitely. We can start with that. There's a lot of knowledge that we can build on and really tailor it specifically towards application for these plant-based foods.
Okay. Well, Robyn, thank you very much. You dwelt on a lot of stuff, looking at the microbes, how they grow, where they come from, how they originate, and then end up in the ingredients. So a lot of things to be done. Holistic approach, very important. Making use of models, so computer modeling. Well, thank you very much for this nice explanation.
You're welcome.
Please subscribe to our webcast. This was NIZO Talks Food and Health, and if you want to know more about this, then please check out our website.
Thanks for your attention. If you enjoyed it, please check out our other episodes via our website and other platforms like Spotify, Apple iTunes, and YouTube. Subscribe through your regular podcast app to make sure you never miss an episode.